Hello and welcome to Rationalizing Radical Expressions 11.2 Part 2. What we're going to look at is longer radical expressions today and see how we want to simplify those things. Same rules as we had last time. Make sure you labeled your notes. And it's good to write down a reminder of these rules that if you have two things being multiplied together, you can break them apart. You want to make sure that one is a perfect square and one of them is not. And then if you've got two radicals, and this is the one we're going to talk about more today, two radicals that are stacked, you can break that up into a radical and another radical. So this is what we were looking at the bottom of our notes last time. So the general idea is you want to break this up into two square roots. You've got your top square root, and then you've got the bottom square root. Should have done that the other way because then the grass goes on top. Oh well. But whatever. So we get 2. If we're trying to simplify the square root of 72, we want to say, okay, well, 72, what's one that I know that's closer? 64, like there can't be anybody closer than that. So 64, does that simplify it? Nope. 64 was 8 squared, so let's try 64 divided by 7 squared. How does that work? Nope. 64 divided by 6 squared, 36. How does that work? Nope. 64 divided by, oh, here, keep track on here, 5, so that would be 25. That work? Nope. Why am I doing 64? I'm trying to do 72. Oh, no. Oh, no. Here, I'm going to get, no, I'll just fix 72. Well, 36. There it is. Okay. Sorry, I was doing all those other ones. But 36 is going to be our best option. But you know the process, hopefully. So we got 36 and the square root of 2. We simplify our 36, we get 6 square roots of 2 over 2. Reminder that anything inside of the radical cannot be touched. So we don't want to do anything to the stuff that is in there. The only thing that we can simplify is we can do this 6 divided by 2. 6 divided by 2 gets us 3. And that square root of 2 is left alone. You cannot do anything to something that's inside of a radical. You can do two radicals together, that's fine. But if it's inside it, you can't do anything with something that is outside of it. We've got square root of 15 over 40, so we got square root of 15 over square root of 40. When we try to simplify 15, I'm going to tell you right now, there's no perfect squares that go into that, so we just kind of leave that alone. And then what happened last time is all of these square roots on the bottom were working out really nicely. I'm going to kind of speed this video up a little bit and tell you that the best we can do with this thing is make a square root of 4 and a square root of 10. If you want to pause the video and check that out for yourself. But that means we get square root of 15 over 2 square roots of 10. And then we can't do any more radical simplifications at that point. And that's a problem because one of the things that we talked about last time, but I said we weren't going to talk about, was, hey, if you've got a square root in the denominator, that's bad. The idea is that you have something that is irrational. Square roots of non-perfect squares are irrational, meaning that you can't turn them into a fraction. The square root of 10 is a number. This number will never repeat and will never end. Yeah, sure, we got a couple 2's, but then it changes to something else. That makes it irrational. If it's in the denominator, that means it's in a fraction. So we have something that can't be a fraction inside of a fraction. That's bad news bears. So we want to try to get it out of the fraction by getting it out of the denominator. To do that, we're going to do this thing called rationalizing the denominator, turning that number into a rational number, something that can be expressed as a fraction, like 3. So what you do is you multiply the top and the bottom by whatever square root you've got sitting around in your denominator. So we've got the square root of 4 and we've got the square root of 3. So if we simplify that, we get 2 over the square root of 3. And that's one of those no-no things. We can't have that square root of 3 chilling in the bottom. So to get rid of it, we multiply it away to the top and the bottom. Now I'm going to do this the long way for this one. So we get 2 square roots of 3 over the square root. When you multiply those two together, you get the square root of 9. Well, hey, the square root of 9, we know what that is. It's 3. So we get 2 square roots of 3 over 3. We can't do anything with those 3's because one of them isn't a radical, so leave it alone. Next one, I've got the square root of 15 over 2, so I'm going to break that up into the square root of 15 over the square root of 2, but we can't do anything to simplify those things. So we're going to get rid of that square root of 2 by multiplying the top and bottom by the square root of 2. In the numerator, we get the square root of 30. In the denominator, we get the square root of 2 times the square root of 2. I'm going to do this in my head. Square root of 2 times the square root of 2, that's the square root of 4, and the square root of 4 is 2. So this is just square root of 30 over 2. Now we can simplify that square root of 30. So we've got 30, closest perfect square is 25. How about that thing? Nope, 30 by 4, that's 16. Nope, 30 by 3, that's 9. I don't think any of these are going to work. Yeah, none of these are going to work. I think I had a good pause in there. So we'll cut all that out. Now the square root of 30, I'm once again going to shorten the video a little bit. I'm going to tell you that it doesn't simplify. You can go ahead and check, pause the video, but the square root of 30 doesn't simplify, so we'll just leave it alone. We can't even do the 30 divided by 2 to make it a square root of 15 because the 30 is inside of a radical, so we cannot touch it. That's it for the front side. You can move on to the back side video or rewatch. See you in a bit.